Is the entire universe flat, or much like a hologram, as new scientific evidence has shown? A new report features substantial evidence which shows that the entire universe and Earth is a hologram. Research report collated by a United Kingdom, Canadian and Italian study has provided what researchers believe is the first observational evidence that our universe could be a vast and complex hologram.
A new study claims to have the first observational evidence that the universe could be a hologram. The work by an international team focuses on irregularities detected in the universe after the Big Bang occurred. They argue that such discrepancies between Einstein's theory of gravity and quantum mechanics could be explained if the universe was, in fact, a hologram. One of the researchers, Kostas Skenderis, has explained the idea is similar to that of ordinary holograms, where a three-dimensional image is encoded in a two-dimensional surface, such as in the hologram on a credit card. However, this time, the entire universe is encoded. As such, the team's work could help to further a concept called quantum gravity, which helps to bridge the gap between the theory of gravity and quantum mechanics. The hypothesis that the universe could be a holographic entity was first introduced in the 1990s. Throughout the years, research has been done to advance the notion, including a mathematical explanation of how holography even works.
Theoretical physicists and astrophysicists, investigating irregularities in the cosmic microwave background, the afterglow of the Big Bang, have found there is substantial evidence supporting a holographic explanation of the universe, in fact, as much as there is for the traditional explanation of these irregularities using the theory of cosmic inflation. A sketch of the timeline of the holographic universe. Time runs from left to right. The far left denotes the holographic phase and the image is blurry because space and time are not yet well defined. At the end of this phase, denoted by the black fluctuating ellipse, the universe enters a geometric phase, which can now be described by Einstein's equations. The cosmic microwave background was emitted about 375,000 years later. Patterns imprinted in it carry information about the very early universe and seed the development of structures of stars and galaxies in the late-time universe, far right. Theoretical physicists and astrophysicists, investigating irregularities in the cosmic microwave background, the afterglow of the Big Bang, have found there is substantial evidence supporting a holographic explanation of the universe, in fact, as much as there is for the traditional explanation of these irregularities using the theory of cosmic inflation. The researchers, from the University of Southampton, UK, University of Waterloo, Canada, Perimeter Institute, Canada, INFN, Lecce, Italy, and the University of Salento, Italy, have published findings in the journal Physical Review Letters. A holographic universe, an idea first suggested in the 1990s, is one where all the information, which makes up our 3D reality, plus time, is contained in a 2D surface on its boundaries. Professor Kostas Skenderis of Mathematical Sciences at the University of Southampton explains, imagine that everything you see, feel, and hear in 3 dimensions, and your perception of time, in fact emanates from a flat two-dimensional field. The idea is similar to that of ordinary holograms where a 3-dimensional image is encoded in a 2-dimensional surface, such as in the hologram on a credit card. However, this time, the entire universe is encoded. Although not an example with holographic properties, it could be thought of as rather like watching a 3D film in a cinema. We see the pictures as having height, width, and crucially, depth when in fact it all originates from a flat 2D screen. The difference, in our 3D universe, is that we can touch objects and the projection is real from our perspective. In recent decades, advances in telescopes and sensing equipment have allowed scientists to detect a vast amount of data hidden in the white noise or microwaves, partly responsible for the random black and white dots you see on an untuned TV, left over from the moment the universe was created. Using this information, the team were able to make complex comparisons between networks of features in the data and quantum field theory. They found that some of the simplest quantum field theories could explain nearly all cosmological observations of the early universe. Professor Skenderis comments, holography is a huge leap forward in the way we think about the structure and creation of the universe. Einstein's theory of general relativity explains almost everything large-scale in the universe very well, but starts to unravel when examining its origins and mechanisms at quantum level. Scientists have been working for decades to combine Einstein's theory of gravity and quantum theory. Some believe the concept of a holographic universe has the potential to reconcile the two. I hope our research takes us another step towards this. The scientists now hope their study will open the door to further our understanding of the early universe and explain how space and time emerged. Thanks for watching. Share and don't forget to leave your comments.